Boots on right and wear your hat so well. So pardon me my laughter, as I sure do understand. Even Moses got excited when he saw the promised land. That's right, you're not from Texas. That's right, you're not from Texas. That's right, you're not from Texas. Texas wants you anyway. That's right, you're not from Texas. That's right, you're not from Texas. That's right, you're not from Texas. Texas wants you anyways. I was born.
Good morning, Geology, Geology, Geology. We are here in beautiful Montrose, Houston downtown with Daniel Minizini. We're gonna give you something to meditate on.
She asked me, babe, what's so great? How come you're always going on about your Lone Star State? I said, that's right, you're not from Texas. That's right, you're not from Texas. That's right, you're not from Texas. Texas wants you anyway. That's right, you're not from Texas. That's right, you're not from Texas. That's right, you're not from Texas. Texas wants you anyway.
So you see, I'm not from Texas. You probably are not from Texas either. But we have somebody here from Texas today. We're gonna have somebody representing Geoscientists Without Borders. And today we're gonna talk about what geoscientists they do for society. We're gonna have a couple of examples. In the first example, we have a direct action of society. Where somebody very rich is chipping on the table to help the governmental agencies and researchers to study the temperature in the oceans. This guy is a co-founder of Microsoft. The second example is another example of how geoscientists they contribute directly to society. This group, Geoscientists Without Borders, is helping societies around the world with different projects per year. Okay, so these are the topic of today. What do geoscientists do for society? So in the very first case, as I said, we have Paul Allen, and he, as I said, is a co-founder of Microsoft. He donated $4 million from his pocket. It seems he has deep pocket, but $4 million is a lot for a project in connection with NOAA, which is the National Oceanic and Atmosphere Administration. So he's going to help NOAA, and in specific, the focal point for this project is Greg Johnson at NOAA. He's going to help him funding some sensors to put at the bottom of the oceans. The bottom of the oceans, they could be 5-6 kilometers deep, 3 or 4 miles deep. So some of the sensors that are used today, they're used for shallower waters. And the sensors, they cannot resist the depth because of the high pressure that you have down there. So you need an extra investment for that. This is the idea. The idea is called deep Argo floats. And these are the sensors that they study temperature and salinity in the deep ocean. The temperature, especially the temperature of the deep oceans, may absorb some of the heat that the planet is receiving. So measuring the location of this heat, the intensity, and the pace of the warming of the deep oceans will help to project the understanding of location, intensity, and velocity of the atmosphere warming. So I'm gonna sum up this project with a haiku. A haiku is a Japanese poem with only 3 lines. So the focal point for this project and study the temperature and salinity at the deep oceans. He is fond of haiku, and these are the 3 lines that he writes about this project. Abyssal ocean, modulating climate change, Deep Argo observes. So we are going to move now to Geoscientists Without Borders. We have in the house Bob Merrill. Good morning, Bob. Do you think that people, they know about Geoscientists Without Borders?
There's not enough awareness, I feel, about Geoscientists Without Borders. It's a program, it's a young program begun in 1968 after the tsunamis in Southeast Asia, because people recognize that geologists have unique capabilities to help solve and bring awareness to communities of these problems.
So tell us again, when is the project conceived, in which years?
In about 2008, following the
2004 tsunami?
Yes.
Okay, all right. You need to do something else to reach out and let the people understand what Geoscientists Without Borders are doing.
That's become my mission, is reaching out to tell people about Geoscience Without Borders.
Okay, so you're very welcome in KPFT Houston and in the HD3 channel to talk about it. We really hope to reach out and to let the people understand the importance and the activities of Geoscientists Without Borders. We would also like to offer you the possibility to pitch if you need any volunteers for Geoscientists Without Borders. And we're going to see now in our conversation if you are going to really need them. In the meanwhile, can you tell us what are the goals of Geoscientists Without Borders?
The goals of Geoscientists Without Borders is, first of all, to strengthen the global geoscience applications using multidisciplinary projects in the geosciences. But these projects have to have humanitarian impacts, and we also want to be sure that there's training, and the programs provide training for the next generation of geoscientists. So it's a twofold process, or program. One, humanitarian needs. Secondly, we want to be providing training for the next generation of geoscientists, because that's important to continue. And then finally, we want to be able to make a significant difference in the lives of those people who are in need, who have the humanitarian needs, and collaborate our activities with the local communities and state governments and other humanitarian organizations.
So when you say humanitarian needs, what do you have in your mind? What is a humanitarian need?
Humanitarian needs would include water quality, water accessibility, and water management. It includes geological hazards such as volcanoes, earthquakes, tsunamis, landslides, floods. It includes soils. We've been involved with a couple of projects looking at soils and agriculture. It also includes habitat management. We've sponsored a project in Lake Tanganyika, for instance, on fisheries. And
so we are here in the radio always in need of funding. By the way, KPFT funded only by listeners like you and me and the several people that are listening to us. Who's funding Geoscientists Without Borders?
Well, the Geoscientists Without Borders is a program sponsored by the Society of Exploration Geophysicists, the SEG, and it's funded through the SEG Foundation. So some contributions to the SEG Foundation then are used to support Geoscientists Without Borders, and then several companies. Geoscientists Without Borders was initially set up and funded by Schlumberger with a very generous donation. Other, particularly oil and gas companies, have contributed sponsorship money. And the committee that I represent today, we evaluate project submittals and choose about 4 a year to fund. About 8 a year are always ongoing.
So you have 8 projects a year, always ongoing, but you fund only 4 projects per year.
Many of the projects are multi-year projects.
Like a couple of years?
Yes, 2 years usually.
Okay. And so I read in your webpage that is Craig Beasley,
Yes.
the founder
Yeah,
of
Craig.
Geoscientists Without Borders. Can you tell us something about Craig and his idea?
Well, Craig decided that geoscientists should support humanity. There's an opportunity for geoscientists with our technology, with our creativity, our understandings of Earth systems, that we had an opportunity to support humanitarian needs around the world. And so with the Schlumberger support initially, we've been able to fund projects to benefit communities that face environmental hardships, they face natural hazards, as well as natural and human-induced disasters, such as the recent Hurricane Harvey.
So is it possible that Geoscientists Without Borders could operate in like Houston?
Given the right project and the right situation, it is conceivable, yes.
Well,
But most of our projects are worldwide. Unfortunately, I can't show you the map, but I can talk about a number of the countries.
oh yeah, this is important. We are at the radio.
That's right.
We don't really like the PowerPoint culture, so in here you can use your words to let people fly high and think about what Geoscientists Without Borders does. And so, by all means, go ahead and tell us these countries and describe them as far as you can, if you have been there.
With respect to earthquake preparedness, for instance, we've done projects in Jamaica. We've had projects in Haiti. We've got a project now in Timor-Leste.
And what do you exactly do for this preparedness?
Well, some of them are to locate the faults and see and understand if the faults, when the earthquake happens, what faults are going to move, what's going to be the impact of those faults, and then communicate that to the communities. In Timor-Leste, the group set up a series of seismic stations that Timor-Leste did not have seismographs set up around the country, so to help understand the earthquake systems there.
And so you give information to the public, or maybe in connection with the government. But then, how do you help the population to react to a tsunami or an earthquake or a landslide?
Well, one of the best examples of that probably is a project on tsunami preparedness that sponsored by USC, and it was on the southern coast of Java. The program evaluated past tsunamis, so they understood the historical, about a 400-year record of tsunamis in Indonesia, and dug ditches, dug pits to understand the stratigraphy, identify where the tsunami deposits were. They built or constructed tsunami inundation maps from the data and as well as from modeling. They took this then to the communities and showed them where the inundations could occur if there is a tsunami. And then finally, together with the communities and governmental organizations, they came up with a program called 20-20-20. And this program, what it means is that if you're in an area and you feel the earth shake for 20 seconds, you have 20 minutes to get 20 meters above the sea level.
20-20-20.
And that was a very successful community involvement program.
What other countries are you present in?
We've done projects in Sweden, Brazil, in landslides, Bosnia, Herzegovina. We've got a project going right now, and it's about finishing up in Peru. Habitat management, I've mentioned the project in Tanzania on fisheries. We've done another one in South Australia.
How many people are involved per project?
It's quite variable. There may be as many as, see, I have an example here.
So we're talking about few people or a dozen people.
Well, we may in one case we might have as many as 10.
Okay.
Then those 10 individuals that are senior, and then we have student involvement. And I saw one project that said they had as many as 40 students involved in the project.
But let's be clear: the Geoscientists Without Borders, this entity, this institution, is not physically present there, right?
That's right. So the way the process works is Geoscientists Without Borders funds proposals. These proposals frequently come from university professors. That brings in our training aspect. So the university professors will identify a need through their work, a humanitarian need, and they'll put together a program with their university, often several universities, perhaps NGOs, other non-governmental organizations. And so you have a group of organizations. You have a principal investigator that's usually from a university. Usually there are universities from the host country. We're training students not only from the U.S., but training students from the host countries as well, so they can become geoscientists and carry on this sort of work in the future.
We are talking with Bob Merrill. It's 7:25 in Houston, KPFT, HD3 channel. It's 7:25. We're talking about Geoscientists Without Borders with Bob Merrill, sitting in the executive committee. And all of you that you are listening, if you have a question, call us at 713-526-8737. Bob, do you have experience traveling in some of these countries during some of these projects?
Well, I've had experience traveling in a number of these countries. I first got interested in this sort of work when my daughter-in-law, who was getting her PhD in nutrition at Johns Hopkins, approached me, or she was showing me the work she was doing, and I commented to her that we can actually do the mapping for her without setting up a regular grid. All she had to do was give me the GPS coordinates of the tube wells she was measuring, and what she was doing was correlating the iron content in the groundwater from each tube well with the iron content in the blood of women of childbearing age. So using our mapping algorithms that geologists use every day, I was able to visually show how, and spatially, how these iron contents varied.
In which country was that?
This was in Bangladesh.
In Bangladesh, but you didn't really go there.
Yes, I've been to Bangladesh 3 times because they were living there.
So what is the perception of geology for people living in a country where it's so flat?
They're very very understanding about it. They understand floods. They know that they're going to have floods. They have earthquakes, so they're concerned about earthquakes. I gave a lecture at a couple of the universities there, talking about oil and gas, because they do have gas resources there.
What did the students ask you? Which kind of students did you have in front of you? Well, I assume they're all locals from Bangladesh.
All local from Bangladesh.
Which kind of questions do they have for a foreign geoscientist coming from USA?
Well, we were talking about gas resources, oil and gas resources. We talked about uncertainty. We talked about how to describe cuttings and cores, how to describe the rocks.
So they were really interested in the energy resources that they have in their
Absolutely, and that
country.
was the reason. That's my experience, and actually at least one of the talks was set up by a geologist that I knew at Unical, but he was with Chevron now.
I'm fascinated by the different perceptions of geology especially from students. Like in Italy, where I come from, we mainly study geology because we think it is like a natural science where we are gonna study the environment and certainly also the geological principles. But we generally enroll for the naturalistic point of view more than the resources point of view. And my understanding is that also in some parts of this nation, like in the East Coast, West Coast maybe, it is more, the drive to study geology is more naturalistic rather than economic.
Well, naturalistic or economic, I think for me, geology is a way of life. You just can't get away from geology wherever you are. So regardless of what you're looking at in the world, there's something geological that's going on that I feel is important to understand. Even recently I was working on some flood relief, just looking at the floods and why this particular neighborhood may have flooded. Could it have been mitigated? Yes, it could have been, but it wasn't. And so here you have environmental issues, you've got planning issues, and I applaud you for going to Washington and talking with our representatives and senators there, because that's very important to have that communication so that all government organizations begin to understand the importance of geology in the life of the communities.
So talking about the importance of geology and going back to Geoscientists Without Borders, can you tell us something specific? I remember reading something about in Kenya, that you were working in Kenya.
Yeah, and actually I wasn't working in Kenya. It was a project that was being done that we funded by, and Paul Bowman was the principal investigator. And the University of Calgary was involved. The Kenyan Water Institute was involved.
So can you tell us?
And what the project entailed?
Setting? What's the setting of Kenya? Why Kenya? What's happening in Kenya?
This project happened to be at the Kakuma refugee camp, which is in northwestern Kenya.
What's going on in that refugee camp?
And these are refugees from South Sudan. It's one of the world's largest refugee camps, or larger refugee camps. The one aspect of the Rift Valley of Kenya is it's quite dry. And this is where the Kakuma refugee camp is located.
We're talking about tens of thousands of people.
We're talking about hundreds of thousands of people. They needed fresh water, and using our geophysical techniques of resistivity and seismic, teaching the people about geophysical data acquisition and how to interpret that work, that data that they get. This would be electrical resistivity, seismic refraction, and then so the group was able to identify a number of locations, optimal locations for drilling water wells. The first 3 wells were drilled based on this work, and these 3 wells had sustainable rates of between 30 and 40 cubic meters of water an hour.
What does it mean? Is a lot?
That's a lot of water, because that's enough water. If you run the wells for 10 hours a day, that's enough water for 57,000 refugees, assuming that 20 liters per person per day.
So how could it be that you have a refugee camp, but nobody is thinking about the quantity of water that these people they need?
Well, they are usually these in this part of the world, they'll dig surface water. So essentially, is adjacent to rivers. The sands will act as aquifers, adjacent that are on the banks. People will dig into the sands and get some water. Well, that's not sufficient when you begin to get 200,000-300,000 people into an area. You have to come up with other sources.
So it's the cultural background, the technique that they use, which is cultural, was not enough to fulfill the requirement of all of these people that all of a sudden they
That's right.
coagulated at the same place.
Right.
And so you arrive there, and what happened once your project is done and you leave? Who's maintaining the outcome of your project?
Well, the local communities are, and as a matter of fact, in that particular project at the Kakuma camp, they had a number of other drilling locations to explore as well. So the results were left with the refugee UNCOR and the other sponsoring organizations. And
So the United Nations community.
United Nations Refugee Organization.
And so, but this is typical of the Geoscientists Without Borders, to conclude a project and hand it over to the local communities, right?
Precisely.
So,
And that local community, not only the local community, but even the local universities. Many of the projects we've trained geoscientists as well as the professors at the local universities. And that work then continues into the future. And often the project will leave equipment at the local university.
So many of the countries where you work in, they are, let's say, underdeveloped or they're not rich countries.
That's right.
And I wonder why the things that Geoscientists Without Borders does is not performed by the local governments. Because it seems that what you do is like very basic. You really need water. How could it be that the local communities, local governments, they don't take care of this?
I believe there are a lot of political issues associated with that. Money doesn't flow downhill always to the local communities.
Can you expand on that?
And these are some of my own observations over the years. Has nothing to do with the Geoscientists Without Borders. I do believe strongly that money and programs should begin at the community level. In other words, if there's some funding available and you need to solve a problem, start with the community, because then all the funds are directed into the community. My observation is that often if the money comes in at the top of the pyramid, some of it gets drained off on the way down and not all of it gets to the community. That's just the way the world seems to work.
What is in the middle, in between the top of the pyramid where you have the government and the base of the pyramid where you have the community?
Well, you have a whole series of organizations. They may be governmental organizations, they may be geological surveys, they may be disaster relief groups.
So there's a dysfunction in general in the world, in the countries that they need these basic needs. There's a disconnect between the top of the pyramid, the government, and the base of the pyramid, the communities with humanitarian needs.
That's right.
And that is where Geoscientists Without Borders, they enter. They enter at the base and they help the communities with humanitarian needs.
Right. Here's another project, for example. We have 2 U.S. universities that were involved. A university in Indonesia, the Indonesian Institute of Community Development, the Indonesian Government Disaster Mitigation Agency, and the Indonesia Institute of Science. So you can see there's a whole series of organizations that have been brought together by the principal investigator to work with to do the work with the community. And Geoscientists Without Borders is just a little part of this, and we're giving a little bit of money to facilitate the work.
Are you going to need volunteers for Geoscientists Without Borders? Do you want talk with the listeners and engage them in some of the activities you do in Geoscientists Without Borders or the SEG?
Well, the committee is not large. We always, every year we add a few people. We have a term limit, if you will, and we add people to the committee. So we're looking for committee members over time. But most of the other than funding, and we love to get the funding, as you know at KPFT, we do need the funding,
Yeah.
because we've established a trust funds and an endowment to fund the programs into the future. So we're trying to fill that and make that happen. But the biggest part for volunteers, and they're not all volunteers, these would be the universities and students to put the programs together. And many of the programs, the results are master's theses and PhD dissertations.
Where can the students or professors that they want to write down a proposal, where can they find the form?
All the forms are located on the Geoscientists Without Borders website. Go to the SEG website and you'll find Geoscientists Without Borders, and all the information is there. Or they can contact me.
Where can they contact you?
rmerrill@cathart.com.
Can you say it again? Can you spell it out?
It's rmerrill, RMERILL, at Cathart, CATHEART.com.
All right. And then I have a final question, because you said you are putting together an endowment. So that means that you're looking for sponsors, and then you have to put aside some of the money. Why private companies they should sponsor these programs?
Well, from a private company perspective, there are two. One, if they're operating these countries, often they want to be able to contribute to the communities that they're working in.
There's a kind of visibility.
A visibility, and sometimes it's a requirement of licenses, resource licenses. And the other part is that we're training geoscientists, and all these companies, if they're going to exist in the future, need geologists and geophysicists. Whether they're in the oil and gas or mining or natural hazards, hydrology, whatever aspect of geology.
So this other aspect would be the workforce.
The workforce. People and companies need young geologists.
Bob, can you tell us something more before you leave? You have been involved your entire life among geoscientists, and off the record you were telling me about this mindset of the multiple working hypothesis. What is your point of view on geoscientists after this long career that you had?
Well, first of all, particularly for young geoscientists, they should all read a paper that was written in the late 19th century by T.C. Chamberlain. It's called the multiple working hypothesis. And the point of that is that when you're working a problem and you're looking for solutions, you develop a series of hypotheses of what could have caused this, caused the outcome that you're studying. Then you pick the one that seems most reasonable to you given the evidence that you have. For instance, I used to tell geologists that it didn't matter if you drilled a dry hole. I just wanted to be certain that the critical risk was evaluated and you ignored the critical risk for some reason. Now, I told this once to a group of Boy Scouts that that I was fortunate if I had, at that time, 1 out of 10 wells was successful, and this young man in the front row looked up at me and said, "And they pay you for that?" I said, "That's right, because the one will pay for the rest."
Well, thank you very, very much, Bob. You are always welcome to come in here and pitch and tell us what is how your projects are doing, and we really welcome you in here. Maybe telling us how the projects that are going on right now, how they end up in a few months or 1 year.
And if people happen to be in Houston next week on Tuesday morning, we have a Geoscientists Without Borders special session at the SEG conference, starting at 8:30. And then, if people want to know more about specific projects and more about Geoscientists Without Borders, I'm giving a talk at the Houston Geological Society on Monday, October the 2nd.
All right. So with this, I really thank you, and we are gonna put some music on. We thank Bob Merrill from representing Geoscientists Without Borders, and we're gonna put some music. And if you want, call me at 713-526-8737. Bob is gonna stay with us a little bit more, so if you have some questions for him, +1 for United States, and then 713, which is for Houston, 526, which is for Montrose, and 8737 for HD3 KPFT Houston. This is Mini Geology Radio Show, and you can call us at 713-526-8737, or you can write at minigeology@gmail.com. Mini, like a little thing, M-I-N-I, geology, and you know how to spell it very well. minigeology@gmail.com. Or you can tweet the hashtag minigeology, or visit the Mini Geology Facebook page. Or you can also Google Mini Geology and Rice University. We just had a new web page that the kind geologists at Rice University, they offer us to write on. So we have there a web page where it explains the Mini Geology project and the passion of reaching out to all of you. So write back at minigeology@gmail.com. We're gonna leave you with that. We had in the house Bob Merrill with Geoscientists Without Borders. We talk a little bit about this project funded by the Microsoft co-founder, Paul Allen, putting $4 million to study the temperature and salinity of the deep water. We couldn't have online my good friend Steve Bergman, because I think it's too early over there. I know that's not the reason. Probably we have a glitch, and this is my cell phone that ran out of battery, so I cannot communicate with him. Anyhow, thank you very much, all of you. Spread the love and the word. KPFT Houston.